Let's talk about opportunity cost and supply, and this connection between a firm's opportunity cost and that firm's supply curve is crucial for everything we do in chapters 6 and 7, and that it all comes, or the insight comes from this first example where we've got Harry riding around all over town on his bicycle, I've got pictured here, looking for aluminum cans that he can get deposits for. And the question we have is, how many hours is he willing to spend searching for cans at various prices? We're given this information, and this is just table, it's example 6.1, the table right there in your reading. And we notice that, as for the first hour he finds 600 cans, the next hour worked he finds 400 more, the next hour 300 more, and so on. I'm just looking at these totals and converting them to changes in how many cans he had as he spends additional hours. And one thing to notice is we've got this diminishing marginal product. The first hour yields a lot more cans than the second, which yields a lot more cans than the third, etc. And why might this occur? Well, in Harry's case, the first ones he can just run through and get the garbage cans in the school cafeterias where there's just tons of them. But if he wants to spend another hour, well, he hit those easy ones, the low-hanging fruit already. He's got to go around and look at campus offices, which are a lot further apart, and you only get one or two each can, so it's gonna be harder. After that, he's got to find them in bushes, etc. And then after that, I don't know where he'd find them, but it gets harder and harder and harder. It's just another application of the low-hanging fruit. In general, we think competitive firms, or we've observed that competitive firms in the short run, and really any firms in the very short run, find upward sloping marginal cost curves, which come from diminishing marginal product functions in a way that we'll see in this example, actually. And the usual explanation is that some factors that a firm uses to make output, so factors are inputs, labor, capital we assume, but capital are buildings, machinery, different types of machinery, different types of skilled labor, unskilled labor, etc. Anyway, these we assume that some factors are fixed in the short run, particularly buildings and machinery. And as we add more and more labor, well, initially we might get big jumps in output as we add more and more and more labor without increasing our number of machines. Well, there isn't enough to keep people busy productively. So we see marginal product fall off, get smaller. And it might even go negative. Of course, the firm would never knowingly hire a worker that led to a negative marginal product unless it's the boss's son. There's other things besides profit that some firms go for it. So we're asked to find the I better get a pen here. The reservation. No, that's supposed to be a Z. There we go. Try one more time. The reservation price for Harry. How high would a price have to be to get him to go hunt 1 hour of cans? How about to get him to go to second hour a can? And the key is that he can work washing dishes for $6 per hour. So the key insight here is he'll go collect cans if he can make more than $6 for that hour. He'll go the first hour if he can make more that hour than he can washing dishes. The second hour, same application of the cost-benefit principle. And so when we ask, well, how high would price have to be to get him to supply 1 hour of labor to the market, or 600 cans? How high would price have to go to get him to spend a second hour? That is, bring his quantity supplied up to 1,000, and so on. The key is that the benefit side of collecting cans is the price of the cans times however many cans that next hour will get him. So P times the marginal product, or the change in the number of cans he'd get by working 1 more hour. If that were just equal to the wage, $6, that would tell us his reservation price. If it's more, he's eager to go collect cans. If they're just equal, that's the minimum he'd need, and that's what we're to go hunt cans instead of washing dishes, and that's what we're looking for. So we can rearrange this expression that they give us into the following form. Well, we can answer the question how high price would have to go just by rearranging this. It would have to go, let's put it in pennies because we'll take that dollars and put it into cents. And we're going to take 600 cents divided by the change in cans. That's what's going on here. So that first hour, notice he gets 600 cans. So we take that 600 cents he'd be given up for that hour of work. We divide through by the increase in cans, and we'd find that would bring him enough money to justify, we'd find the price that would bring in enough money to justify him collecting cans rather than washing dishes. So 600, we look at delta Q, that's 600. It would have to be 1 cent per can. And then notice that the second hour, he gets 400 new cans. He still would have to give up $6 or 600 cents to work, to walk away from the job washing dishes to go work collecting cans. So 600 divided by 400 is 1.5. And these are all in cents per can. And so on. The price would need to go up to 2 cents per can to get him to work a third hour. Notice that third hour gets him 300 more cans. The price would have to rise to 3 cents a can to get him to go that fourth hour. And finally, the price would have to jump all the way up to a sky-high 6 cents per can to get him to spend a full 5 hours looking for cans. That's where that information comes from. Then that individual supply curve in graphical form just comes from taking this supply curve that I just brought over from the last bit of calculation we did and plot price against the y-axis, plot price on the y-axis. Let's just scale it approximately right. And then we'll just do quantity. We're asked to indicate how many cans total he'd be willing to supply at these various prices. So we use the total quantity he'd gather. This would be 800. And then 1, 2, 3. Split those in half, and I should have hundreds. 1, 2, 3. I think that's roughly right. All right, so now let's just plot at a price of 1 cent. He'd be willing to supply 1, 2, 3, 4, 5, 6, 100 cans. That's an 800. At a price of 1.5 cents, he'd be willing to up his can production to 1,000. At a price of 2 cents, he'd be willing to go up to 1,300, 1, 2, 3, and so on. At a price of 3 cents, he'd be willing to go up to 1,500. Notice it starts getting pretty darn steep here. Pardon my less than artistic hand here. And then we just connect the dots, and we have his marginal cost curve. But by that logic, we know that this is also his supply curve. The supply curve for the competitive firm is equal to that firm's marginal cost function. One more thing in this, I'm going to talk about the next section here. The next section of the reading talks about how we get from individual firm supply curves to the market supply curve. And the easiest way to see this is just to assume there's two. And if we've got two identical firms at a price of 1 cent, they're each supplying 600 cans per day. Well, we add those quantities up and we get 1,200 supplied to market by these two firms. At a price of 600, they're each supplying 1,600, 6 cents, sorry, they're each supplying 1,600 cans. When we look at what the market supply is 3,200. And we did an example in class where we had 100 identical firms, or it could be 1,000. I think the text goes on to talk about 1,000 identical firms. So simply put, we aggregate across the quantity produced by individual firms at any given price to get to the market supply. Notice the price units are the same for the firms and for the market, but the quantity units are different. These are the firm quantities. This is the market quantity. And that difference becomes really big once we have 100 firms or 1,000 firms or whatever. And you'll see that in a future screencast.
Made with Doodlecast Pro.